You do it about 20,000 times a day. You never think about it. It keeps you alive without asking for anything in return. But here is the strange part. You have been doing it wrong, and the consequences are stranger than you could imagine. This is the story of breath, not the poetic kind, the mechanical kind, the ancient kind. And once you understand what is actually happening inside your body when you inhale, you will never take a breath the same way again. Take a breath right now. Notice how you did it. Chances are your chest lifted. Your shoulders may have risen slightly. The air came in through your mouth or nose and filled the upper third of your lungs. That is what most people do. That is what most modern humans do. And according to James Nestor, science journalist and author of Breath, that pattern is one of the most quietly destructive things your body does every single day. Your lungs are not shaped the way most people imagine. They are not two identical balloons sitting side by side in your chest. They are wider at the bottom than at the top. The bottom lobes hold far more air. And those bottom lobes are where the majority of your oxygen-absorbing tissue lives. When you breathe into your chest, you are filling the smallest, least efficient part of your lungs first. You are leaving most of your own breathing capacity completely unused. This is not a small inefficiency. This is not a minor quirk. This is a fundamental mismatch between how your body was designed to work and how you actually use it. Your diaphragm is a dome-shaped muscle that sits just below your lungs. When it contracts, it pushes downward, and your abdomen expands outward. That expansion pulls air deep into the lower lobes, the wide, dense, oxygen-rich part of your lungs. This is diaphragmatic breathing. This is how your body was built to breathe. This is how infants breathe, before the world teaches them to do otherwise. Watch a sleeping baby sometime. Their belly rises and falls. Their chest barely moves. That is not a coincidence. So, what happened? Why do so many adults breathe in a way that contradicts their own anatomy? Part of the answer is posture. Modern humans spend extraordinary amounts of time hunched forward, over desks, over phones, over steering wheels. That forward curve compresses the diaphragm. It physically restricts its range of motion. Over time, the body adapts. It finds another way to get air in. It recruits the muscles of the neck, the shoulders, the upper chest. These muscles were not designed for this job, but they will do it. And gradually, shallow chest breathing becomes the default pattern that feels normal. Part of the answer is also stress. When your nervous system detects threat, whether real or imagined, it activates your sympathetic nervous system. Your heart rate increases, your muscles tighten, and your breathing shifts upward into your chest. This is the emergency breathing pattern. It is efficient for a sprint. It is not efficient for a regular Tuesday afternoon. But if your brain has decided that the world is a place of constant low-grade threat, your breathing never fully returns to the deep, slow rhythm that the body actually prefers. There is a feedback loop here that most people never realize. Chest breathing signals danger to your nervous system. Your nervous system interprets shallow, rapid breathing as evidence that something is wrong. So it stays in a mild state of alert, which keeps your breathing shallow, which keeps your nervous system activated. This is not a metaphor. This is physiology. Dr. Patricia Gerbarg, a psychiatrist at New York Medical College who has spent decades studying breath-based interventions, describes this loop as one of the hidden drivers of chronic anxiety. Not the cause of anxiety, but a silent amplifier, a physiological echo chamber that keeps the nervous system from ever fully downregulating, even when there is no real threat present. Now let us go further back, because this is not just about posture and stress. The problem runs much deeper, and it starts in your face. Dr. John Mew was a British orthodontist who spent his career studying facial development, specifically why human jaws and airways have changed so dramatically over the last few hundred years. His work, and later his son Mike Mew's continuation of it, proposed a framework called orthotropics. The central claim is that the shape of your face, your jaw, your palate, and your airway are not fixed by genetics alone. They are shaped in large part by how you hold your tongue, how you chew, and how you breathe. Here is the specific mechanism. When you breathe through your nose, your tongue rests on the roof of your mouth. That upward pressure from the tongue acts as a natural scaffold that keeps the palate wide and the upper jaw broad. Broad palate, wide nasal passage, clear airway. When you breathe through your mouth, as millions of people do, especially at night, the tongue drops. The upward pressure disappears. Over time, particularly during childhood development when the bones are still malleable, the palate narrows. The nasal passage narrows with it. And once the nasal passage is narrower, breathing through the nose becomes harder. So the mouth opens more, which narrows the passage further. This is a developmental spiral, and it does not stop at aesthetics. A narrowed airway is the direct upstream cause of obstructive sleep apnea, the condition in which your airway collapses repeatedly during sleep, waking your brain dozens or hundreds of times a night to restore breathing. Sleep apnea has been linked to increased risk of cardiovascular disease, type 2 diabetes, depression, and cognitive decline. It is estimated that over 1 billion people worldwide have some form of it. Most do not know. You may be one of them. If you wake up tired even after 8 hours of sleep, if you snore, if you grind your teeth at night, if you need coffee to feel human before 10 a.m., these are potential signals, not certainties, but signals worth examining. The Stanford professor of otolaryngology, Jayakar Nayak, has spent years studying airway anatomy and the upstream causes of sleep-disordered breathing. His work connects the anatomical shifts in the modern human face to changes in diet, specifically the shift away from tough, fibrous foods that required heavy chewing towards soft, processed foods that require almost none. Your jaw muscles, like all muscles, respond to load. Less chewing means less muscular development in the jaw. Less muscular development means less structural support for the airway. Your great-great-grandparents chewed harder food for longer, and their airways were wider for it. This is not speculation. Comparisons of pre-industrial and modern human skulls show measurable differences in jaw width, palate breadth, and nasal cavity size. The shift happened fast. In evolutionary terms, it happened almost instantly. Here is the part that stops most people. Breathing through your nose is not just about filtering air. Your nose does something your mouth cannot do. The nasal passage produces nitric oxide, a molecule that dilates your blood vessels, improves oxygen exchange in the lungs, and has antifungal, antibacterial, and antiviral properties. Every breath through your nose delivers a small, steady dose of this compound directly into your lungs. Every breath through your mouth bypasses it entirely. Nasal breathing also slows your respiration rate. Slower breathing means carbon dioxide has more time to build up in the bloodstream. That sounds counterintuitive. Carbon dioxide is the thing you want to exhale, right? But it is actually the primary trigger that tells your red blood cells to release their oxygen into your tissues. Without sufficient CO2, the oxygen in your blood can literally stay bound to your red blood cells instead of reaching your muscles, your organs, your brain. This is called the Bohr Effect. It was described by Danish physiologist Christian Bohr in 1904, and it is one of the most underappreciated facts in all of respiratory physiology. Breathing faster does not necessarily get more oxygen into your tissues. It can do the opposite. The modern habit of overbreathing, taking too many breaths per minute, exhaling too much CO2, keeping the blood too alkaline, may be quietly starving your tissues of the oxygen they are supposed to receive. The air is going in, the oxygen is being absorbed, but it is not being released where it needs to go. So what does the research suggest you do about it? The most rigorously studied intervention is nasal breathing. Just that. Close your mouth. Breathe through your nose, even during mild to moderate exercise. Athletes who train themselves to do this report adaptation within a few weeks. Initial discomfort, then a measurable increase in endurance and recovery. The military has studied this. Elite freediving communities have built entire training philosophies around it. The second is diaphragmatic breathing practice, not yoga breathing as a performance. As a daily recalibration, lying flat, placing one hand on your chest and one on your belly, and training your body to breathe so that the lower hand rises and the upper hand stays still. 5 minutes, 10 minutes, over weeks, this rewires the default pattern. The nervous system follows. The stress loop interrupts. Some researchers, including Nestor, point to a specific breathing rate, roughly 5.5 seconds in, 5.5 seconds out, as the pattern that most consistently activates the parasympathetic nervous system, lowers blood pressure, and improves heart rate variability. It is not magic. It is resonance frequency breathing. The vagus nerve responds to it. Your body already knows how. And this brings us back to the beginning. You do it about 20,000 times a day. You never think about it, but right now, in this moment, something has shifted. You are thinking about it. Your tongue is on the roof of your mouth, or it is not. Your belly is moving, or your chest is. You are breathing through your nose, or you are not. The difference between those two things is not dramatic. It does not look like anything from the outside. But over a lifetime, over 20,000 breaths a day, every day for decades, the difference in what that does to your face, your sleep, your nervous system, your cardiovascular health, and your cognitive performance may be larger than almost any other single habit you have. You have been breathing your whole life. The question is whether you have ever actually learned how.